Welcome to Homework Lib.
We're going to have two different questions. The first one is going to be the non-volatile compound propylene glycol in a quantity of 0.4 mole, which is going to be our solute, is added to 13.6 mole of water. What is the vapor pressure of the solution? And this can be solved employing Raoult's law, which tells us that the partial pressure of a component, in this case the partial pressure of water, is going to be equal to the fraction of water times the vapor pressure of water under standard conditions. In this case, since we have a non-volatile solute, then we don't need to add any other factor, and we can get the final result simply by finding the mole fraction of water. In this case, the mole fraction of water is going to be equal to amount of mole of water divided by total amount, which becomes 13.6 mole divided by the total amount, which is 14 mole, which is 13.6 divided by 14, 0.971. Well, 0.97143, just to make it extra accurate. And we want to know the pressure of water, which is going to be multiplying these two values. The value of P0 of water would be 19.5 torr. So we're going to get 0.97143 times 19.5 torr under the required conditions. This is going to give us 18.94, which rounding up to three significant digits corresponds to 18.9 over here. For the next one, we want to know the molality of a solution made by dissolving 182 grams of sucrose in 217 grams for water. Remember that for molality, we're going to have amount of mole of solute divided by kilogram of solvent. So in this case, the molality is going to be equal to, we're going to put down the mass of sucrose divided by the mass of water, 217 grams of water. And we're going to employ conversion factors to get to this formula. First of all, we know that each mole of sucrose corresponds to 342.3 grams, according to the molar mass of the compound. And we know that in 1000 grams of water, we're going to have 1 kilogram of water. This is going to give us the direct result in molality because we're going to have mole of solute, in this case mole of sucrose, divided by kilogram of water or solvent, which corresponds to a solution of 2.46 mole per kilogram or 2.46 molal solution. So the correct answer would be this one. So that would be all. Thank you very much and have a good one.